So, hello everyone. Good day. I am Ariel Lamsen and this is my report in general chemistry, water auto-ionization, constant Kw. Uy, nangyari. Wait lang po. Yeah, water auto-ionization, constant. In this analysis of acid and base ionization, we see that water in one case plays the role of a base and the other plays the role of an acid. Indeed, the role that water plays in an aqueous equilibrium can be used as another definition of acid or base. So ano nga po ba itong auto-ionization? Water auto-ionization or auto-ionization equation for water is a proton is transferred from one water molecule to another to produce a hydronium ion or H3O plus and a hydroxide ion or OH minus. The equilibrium expression for this reaction is Kw is equal to open bracket H3O plus close bracket and open bracket OH minus and close bracket. So, paano nga po ito? Paano nga po ito nangyayari? So, ito po. Here is how it works. Number 1, a general base ionization reaction is H2O plus B AQ and HB plus AQ plus OH minus AQ KB. So, ano nga po ba itong I na to or L na to? Yung L po na to, ibig sabihin yan, ito pong, yan, yung L na nasa gilid ng H2O is liquid phase. And ito pong AQ naman is aqueous phase. Yan po yung ibig sabihin ng mga yan. And then, next po is yung ionization reaction of its conjugate acid. Ito po yun, HB plus AQ plus H2O and H3O plus B Ka. So, paano nga po ito mangyayari? So, pag pinag-add po natin itong dalawang to, general base ionization reaction, itong ionization reaction of its conjugate acid, ito po ang kakalabasan nila. Ito pong reaction na to. So, ang reaction na to, ito na po yung magsisilbing parang equation natin para magamit yung auto-ionization of water. Ayan po yun. 2H2O and H3O plus OH minus Kw. Yan nga po, auto-ionization of water. Yan, dyan na po natin yung magagamit. So, paano po? Siyempre, may formula po tayo dyan. And the formula is Kw is equal to Ka Kb. And then ito po. And its equilibrium constant is known as the water auto-ionization constant Kw at 25 degrees Celsius. So, ito pong nakikita nyo sa baba. Wait lang. Baka naririnig nyo po yung ingay sa likod. Napapasayo na din ako. So, ito na po. Kw is equal to H3O plus and OH minus. So, equivalent po siya sa 1 times 10 raised to negative 14. Paano po nakuha to? Nakuha po ito dahil po dito sa temperature na given. So, ito pong Kw na constant is, ano po siya, temperature dependent. So, ito pong pag nagbago itong temperature nito, iba yung temperature na binigyan doon sa given problem o sa equation, magbabago rin po yung value niya dito. So, dahil nga po 25 degrees Celsius po yung nakalagay, ang value niya po is 1 times 10 raised to negative 14. So, para mas malinaw po yung steps kung paano po ginagawa yun, magpapanood po ng video.
Problems associated with the auto-ionization of water. So let's start with this one. We're given a concentration of H3O+, also known as the hydronium ion. And our goal is to calculate the concentration of hydroxide at 25 degrees Celsius. So what formula do we need to use? Now let's talk about the autoionization of water. Water can react with itself to form two ions. The hydronium ion, H3O+, and the hydroxide ion. So, this water molecule acts as the acid. It donates the proton. And this one acts as a base. It accepts the proton. And so we get the conjugate acid, H3O+, and the conjugate base, hydroxide. Because water can act as an acid and as a base, it's known as an amphoteric substance. Now, the equilibrium expression.
Ay, saan na? Sorry. So, pause ko lang po. Sinabi niya po dito sa video is amphoteric substance. Yun nga daw po is yung ang amphoteric substance, yun po yung mga substance na can act as a base and a acid. It is known as amphoteric substance. Yun nga daw po yun yung kayang mag-act as base and acid. Yun po.
And this one acts as a base. It accepts the proton. And so we get the conjugate acid, H3O+, and the conjugate base, hydroxide. Because water can act as an acid and as a base, it's known as an amphoteric substance. Now, the equilibrium expression for this reaction is going to be H3O+ times OH-. Now, this is dissolved in water, so it's in the aqueous phase. Now, water is in the liquid phase, so we cannot include it in the equilibrium expression. So you shouldn't write H2O squared on the bottom. So this is the ion product constant, Kw, and it's equal to the product of H3O+ and OH-. Now, at 25 degrees Celsius, Kw is 1 times 10 to the negative 14. Now, this value changes with temperature, so keep that in mind.
So, yun nga po, sinabi ko kanina, nagbabago nga daw po yung value nitong Kw kapag nagbago rin po yung nakalagay dito na Celsius o temperature.
Temperature depending. So now we can calculate the concentration of hydroxide. It's simply going to be Kw, which is 1 times 10 to the minus 14, divided by the hydronium concentration of H3O+. So we have to take that number divided by 2 times 10 to the minus 6. And so the hydroxide concentration in this example is 5 times 10 to the negative 9 moles per liter, or molarity. So that's it for this problem. How to solve problem.
So, yun po. Ipapaalala ko lang din po kung ano yung part na nandito. So, yung una pong nakalagay dito na H2O, yan po yung base or yung nag-a-accept ng proton, and ito naman pong sumunod na H2O is yung acid na nagdo-donate ng proton. So ito naman pong H3O+ is yung conjugate acid, and ito pong OH is yung conjugate base. And then ito na po yung final answer, 5x10 5 times 10 raised to negative 9 M. So, ayun lang po lahat dito sa may water autoionization. Sana po meron kayong naging idea kahit pa paano. Thank you po. Kung mas marami po kayong alam sa akin sa autoionization, sana po turuan nyo din ako. Kasi nahirapan din po ako dito eh. Thank you po.
For this problem, how to solve problem.